Have you ever noticed how fast Google can, say, translate a sign in a photo? Or
Yeah.
search through just a mountain of data?
Oh, yeah, it happens in a blink.
It's incredible. And a lot of that speed comes down to this one secret weapon they have tucked away in their data centers. It's called the Tensor Processing Unit, or TPU.
That's right. And for this deep dive, we're going to unpack what that is. A TPU is it's what's called an application-specific integrated circuit.
Okay, so a specialized chip.
Exactly. Built for one job and one job only. The specific type of math used in deep learning, it's all about handling these massive data arrays they call tensors.
Which brings up the big question, right? Why did a company like Google, which is already a giant in computing, have to go and build its own custom chip? I mean, why not just use CPUs or, powerful GPUs?
It came down to a crisis of scale. This was around 2013. Google did the math and realized that for their new neural networks, things like Google Brain, the computational demand was just exploding.
It's exploding.
Well, if they kept going with the hardware they had would have had to literally double their number of data centers worldwide.
Double them.
Yeah.
That's completely unsustainable.
Totally. So it was a necessity. The TPU project was basically an emergency response, and they designed and deployed that first version in just 15 months.
Wow. So that first version, the TPU V1, what did it do?
It focused on one thing, inference. That's just running an already trained model.
Yeah.
And the results were, well, they were immediate.
How immediate?
We're talking 15 to 30 times higher performance than the CPUs and GPUs of the day. And the efficiency was even more stunning, like 30 to 80 times better performance per watt.
Okay, that's a massive leap. How did they pull that off? What was the technical trick?
A huge part of it was a concept called quantization.
Quantization, right.
So traditional high-performance computing uses these very precise 32-bit floating point numbers. The TPU team decided, for inference, to just not do that. They designed it to work with much simpler 8-bit integers.
But wait, if you drop the precision from 32-bit all the way down to 8-bit, doesn't that make your AI models less accurate?
That is the critical insight. They discovered that for just running the model, that 8-bit precision was good enough for most things, like search or translation.
So they sacrificed a little bit of that numerical perfection for a huge gain in efficiency.
A huge game. It just slashes the amount of memory and power you need for every single calculation.
And at the heart of all this is something called the matrix multiplier unit, the MXU.
And inside the MXU is the real secret sauce, a systolic array.
Okay, that sounds pretty technical. Is there a simple way to think about it?
Yeah, think of it less like a computer chip and more like a perfectly engineered assembly line for math.
An assembly line.
Exactly. Instead of data running back and forth to memory all the time, which is slow, it just flows rhythmically across this massive grid of processors. It reuses every piece of data over and over again. Immensely efficient.
So that first chip proved the concept, but it was internal, inference only. Where do they go from there?
Well, next they needed to train the models faster, too. So TPU V2, which came out in 2017, added training support, and that was the first one they launched on Google Cloud for everyone else to use.
And the scaling just kept going up.
Oh, relentlessly. By the time TPU V4 came out in 2020, you could get a pod with over 4,000 of these chips all working together.
4,000. How do you even keep a system that massive running reliably?
With more specialized hardware, of course. They developed something called optical circuit switches, or OCCs. They can literally reroute the connections in the supercomputer on the fly to bypass any failures.
So this kind of dynamic, specialized infrastructure is really the key. And, if you're a business owner trying to figure out where specialized AI agents or custom integrations can make an impact, getting expert help is crucial.
For sure.
That's why you should check out our sponsor, embersilk.com. They can help with all your AI training, automation, and software development needs.
So looking ahead now, the newest generation, which is called Ironwood, or TPU V7, it's all about this new age of inference. Think real-time reasoning for huge language models and AI agents.
How big can those systems get?
The pods for Ironwood can support over 9,000 chips.
It's just amazing. And this whole focus on specialized hardware isn't just about raw power, right? It's also about sustainability.
Absolutely. Because these chips are so efficient at their one job, they end up producing about 20 times less operational CO2 equivalent than training on a more general-purpose accelerator in a typical data center.
That's a profound difference. The efficiency gains are they're expanding what's possible.
They are. And it really offers incredible hope for solving some of the world's most foundational problems, maybe even ones we can't fully see yet.
It really makes you wonder, doesn't it? What problem will these dedicated supercomputers help us solve next that we can barely even imagine today? a great thought to end on.
It is. And hey, if you enjoyed this deep dive, please subscribe to the show.
Yeah, and maybe leave us a 5-star review if you can. Really does help get the word out. Thanks for tuning in.